Hi everyone, in today's lesson I'm going to talk about how we can solve word problems involving trigonometry. So let's read this word problem together. If you feel like you need to write it down on a separate sheet of paper, feel free to pause the video and do so, and then hit resume when you're ready to continue. So this is a true story, by the way. Las Vegas's high roller is currently the tallest Ferris wheel in the world. It takes riders 30 minutes to go around one time, reaching 550 feet above ground at its highest point. The diameter of the wheel is 520 feet. Situated on the strip, each 225 square foot cabin weighs approximately 44,000 pounds and is equipped with 8 flat screen TVs. Wow, first off, that's insane. So the questions that I'm asking you about this is, what would be the height above ground that passengers enter the Ferris wheel? So let's just analyze what we read and pick out some key features. So it tells us that it reaches 550 feet above ground at its highest point. So that would show me that from here to here, this distance from the ground and the bottom is approximately 550 feet. So I'm just going to put 550, this whole distance. Then it tells us that the diameter of the wheel is 520 feet. So I'm going to go ahead and label that with 520. So this distance from here to here, right, that's the diameter of the wheel, is 520 feet. So the rest of this information, talking about each of the cabins, that's just extra information, kind of just to show you how big this Ferris wheel actually is. So let's see if we can answer our question now. At what height above ground, it should say what height above ground do passengers enter the Ferris wheel? So, I mean, if it starts from the ground and goes all the way up at 550 and from here to here is 520, I think you could easily figure out, people walk up some stairs and then they start here, right? So I'm thinking this distance would be 520 plus 30 gives me 550. So I'm going to go ahead and label this distance from here to here as 30 feet. So to answer the question, at what height above ground do passengers enter the Ferris wheel? That answer is 30 feet above ground. Okay, so let's see if we could answer the second question now. Let's see if we could draw one full rotation around a Ferris wheel. So I'm going to draw just a sketch like this in the first quadrant. And I'm going to have the amount of time be on the x-axis. And on the y-axis, I'm going to put the height. Okay, so we know that the Ferris wheel goes up to 550 feet at its highest. So I'm going to go ahead and label that right here. And again, this is a sketch. It doesn't have to be perfect. 550. So now you want to ask yourself, what is the lowest that this Ferris wheel goes, right? It doesn't go down to 0 on the ground. The lowest that it'll go is 30 feet above the ground. Think about it. You start at 30 feet, you get in the cabin, you go up and around. So you're going 30, then back up to that 550, back down to 30, back up to 550. So my minimum height is going to be down here, which I'll put as 30. And it tells us the time. I believe we didn't need it for the first part, but we can say it here. It takes riders 30 minutes to go around one time. So that is a full cycle. So let's just draw it out first. So we start the Ferris wheel at 30, right? We're always going to start right down there at 30. And we're going to go up to 550 and then back down to 30. And at this specific time, we're at 30 minutes, right? So if we look and analyze this, what type of graph does this look like to you? Does it look like a sine graph or does it look like a cosine graph? Well, you should be saying it actually looks like a negative cosine graph. So negative cosine graph. We're going to need that information tomorrow, but it's just something cool to observe right now. Now, some other things that we can do when we're drawing our sketch is that we could realize that we are going to reach the top, the 550 marker, halfway in the ride. So how many minutes is that? That's probably only 15 minutes, right? So that's going to be my maximum height that I reach, right? 15 minutes in. So that's it. That's my picture, that's the sketch. We started from 30, we went up, and then we went back down. So now let's see if we can answer some questions. They ask us, what is the period of the graph? Well, you should go back to your definitions of period. Period is how long it takes to make one cycle. So how long to make one cycle. And we have that answer. It takes 30 minutes to make one full rotation. So this answer is 30. Or you could be more specific and say 30 minutes. That's the period. And then the other question that they could ask us is, what is the midline of this graph? So we have the minimum that it goes, and we have the maximum that it goes. But what if I asked you to tell me, what is the middle height? What's the midline? So you should be remembering from before, from the video yesterday, that the midline is the max value plus the min value divided by 2. So my maximum value is 550, my minimum value is 30, add them up and divide by 2. And if you do that calculation, you get approximately, exactly 290. So this is 290 feet would be the midline. Now, you're probably wondering why I'm asking you about the midline or the period. Now, this information will help us when I'm eventually going to ask you to write the equation of this curve. So for now, I just want to analyze the things that we see and the things that we can get from the picture. So let's try one more example together. So here's example number 2. We're talking about Johnny. Johnny loves to ride the Ferris wheel at Great Adventure. The diameter of this wheel is 80 feet. So I'm actually going to not read the rest of it, and I'm going to kind of take that information and label my picture. So a diameter of 80 feet. So if we look at our Ferris wheel, from here to here is my diameter. So that's 80 feet. It tells us that it takes 4 minutes for the wheel to make one full rotation. You should be thinking period for that. So if you want to even write that on the side, so this is eventually going to be my period if I need it. And what else do they tell you? They tell you that Johnny begins the ride at 10 feet above ground. So here is above ground, right? Here's the ground. And he starts above ground, right? Here's where he would enter, at 10 feet above ground. So let's see if we have enough information to answer question number 1. So question 1 says, what is the maximum height above ground that Johnny will reach? Well, if this is the tippy top of the Ferris wheel and he started 10 feet above and this is 80, this distance right here is his maximum height. So if I just add 80 plus 10, I get 90. So 90 feet above ground would be the answer to that question. Then it says, what is the minimum height above ground that Johnny will reach? Well, he starts at 10 feet above the ground and goes up and down, but his minimum never goes below 10. So we can say that his minimum height above ground is 10 feet. Okay, let's draw one full rotation around this Ferris wheel. So just like before, we're going to put our time on the x-axis and our height on the y-axis. So we know that Johnny enters the Ferris wheel at 10 feet above ground, so we can go ahead and put 10 here. And we know he'll reach 90 feet above ground, which is here. And we also know that it will take him 4 minutes to make one full rotation. So I'm going to go ahead and put 4 minutes here. And let's draw a sketch. So we start the curve at 10 feet above ground. We go up to about 90 and back down to 10. And that's my curve. So again, you should notice that this Ferris wheel curve looks like a negative cosine graph. So negative cosine graph. Again, that's important for later, but for now, just recognize that that's what you see. So if I wanted to analyze this graph a little bit more, at what time would I reach my maximum height? Well, you should be thinking if it takes 4 minutes to do the whole thing, then it's going to take about 2 minutes to do the maximum height of 90. So the question now asks, question number 4, what is the period of the graph? And again, from before, period is how long it takes to make one full rotation. So here's one full rotation, took 4 minutes. And then I could also ask you a question like number 5, what is the midline of the graph? So the midline is exactly what it means, the middle of the max and the min. So midline, again, for the formula is max plus min divided by 2. So the maximum height is 90, the minimum height is 10. Add those up and divide by 2, and you get 50. So 50 is my midline. So we can actually take all of this information now and we can write a trigonometric equation for the path that this Ferris wheel takes. It goes up and then it goes down. Notice we said this was a negative cosine curve, so now we can actually make the equation. So this is the information we have. We have the midline is 50, we have the period is 4, and we have this picture. So let's refresh our memories as to what composes an equation. So remember, we have y equals some amplitude cos bx plus or minus d. So in this order, remember the absolute value of a is the amplitude. So here's our amplitude. Here is my frequency or my number of cycles. And here is my vertical shift or my midline. So let's see what we can do first. Well, it's obvious that my midline is 50, so I can actually go ahead and label my midline as 50. It's going to be a plus 50, obviously, because we're in a positive 50. We know we can calculate the amplitude by looking at the distance from the maximum to the midline. So that's, if I'm going and starting at 50 and I'm going up to 90, clearly the amplitude is 40. But when we're writing our equation, we have to remember to put a negative in front because it's a negative cosine graph starting at the minimum. So the negative 40, we have the vertical shift of plus 50, and then really the only thing we need is our frequencies and number of cycles. And that can actually come from our period. So we know that period is equal to 2 pi over b. So I'm going to plug in the fact that my period is 4. So I'm going to put that in for p. So p is 4. And I'm going to cross multiply and solve for b. So I'm going to put the 4 over 1 and cross multiply. So we get 4b equals 2 pi. Divide both sides by 4. And 2/4 is reduces to 1/2. So my b value, or my frequency or number of cycles, is simply pi over 2. So my equation of this graph is y equals negative 40 cos pi over 2x plus 50. That is my equation of this Ferris wheel. All right, that's it for today. If you guys have any questions, please jot them down and let us know tomorrow in class. Have a good night.